All right. Hey, everybody. I'm Steven Fletcher. I own WebFletch. I've been programming about 20 years and started my company in 2007 and use it, adjust it, be high for me. That works. So in 2007, I started my company because I wanted to do programming sort of the way that I saw it was going, service-oriented programming, and so I did a little bit in 2007. I've been doing it more and more since then. There's been an evolution of service-oriented programming since about the late 90s, and I think it's really catching on, especially with microservices and all that sort of stuff. So I do talks like this now. So why am I doing this? The last couple places that I worked at, last few places I worked at, they'll interview me for solid principles and test-driven development and microservices and, oh, you know all this stuff, that's really cool. And then when I start and they look at my code and they're like, what is this? This isn't object-oriented. This is breaking all the object-oriented programming rules. Well, it's not object-oriented programming, it's service-oriented programming. So it really scares OO people whenever they're looking at service-oriented programming, and it doesn't follow. And I go into some of that here in a little bit. So does anyone here do service-oriented programming? Not specifically, a couple people. It's the same thing, or its roots are in layered or n-tiered programming, or onion model, or there's a couple other names for it. The idea is, actually I'll get into the idea a little bit later. The idea is object-oriented programming is programming with rich models, which means that after leaving procedural, object-oriented had where you marry data with process. And so service-oriented programming breaks that, where they use anemic models instead. And with anemic models, you take that process back out of the objects and you put it into service classes. So a good point of that is like the repository model, or anything that takes any services that take functionality out of a class and puts it somewhere else is sort of on the steps to becoming service-oriented programming. Anemic means something different these days than it did back in the old days, which was purely anemic, but I'll go into that also in a second. So this is sort of what I was talking about. This is the response that you get when an object-oriented person reads your code. So that's me there pointing at the house is not on fire. My response is, your house is on fire and mine isn't, so who's really doing it wrong? So with service-oriented programming, when people read it, they'll say, this is not object-oriented. And you say, well, I'm not doing object-oriented. I'm keeping this house from catching fire over here. You do your thing, I'll do my thing. The rules of object-oriented programming, inheritance, encapsulation, and polymorphism, none of which were created by object-oriented programming. Actually, inheritance was broken by object-oriented programming. In C, there was no inheritance, encapsulation. In C, there was no encapsulation. It was just perfectly encapsulated in your modules, and there's no way to access it unless you put it in a header file. Service-oriented programming doesn't care. In service-oriented programming, you can do inheritance, but you prefer composition over inheritance. Has anyone ever prefer composition over inheritance before? That's a very service-oriented programming term. You prefer dependency injection, especially constructor dependency injection, and the same thing with the encapsulation and polymorphism. Service-oriented, those are very rich model object-oriented ideas that service-oriented programmers just don't care about. The law of Demeter. Surprisingly, I guess a lot of people haven't heard of this law, but it's a very object-oriented programming, which say if I have a customer, or if I have a human, and then the human has a heart, and a heart has chambers, and the chambers have veins, and the veins can have this sort of functionality. This is all the stuff that a vein class can do. Then whenever I have a person, I shouldn't be reaching into the property that is the heart, and then reaching down to the property that is the vein, and reaching down and then calling those methods. The law of Demeter says that you want to not reach into your properties very deep to call methods on them. You just call the methods on the property, on the method that you're working with. Service-oriented programming, since you separate your data from your process, your model, your customer model, your person model won't have process on it. So you can reach into the properties to do introspection or look into the properties to see what their values are, but there's no way to call methods on it. So once again, another law that we don't care about. Oh no, how do I go back? Yes, self-maintaining. Took a long time to find that picture, so I'm going to show it to you. Service-oriented programming is self-maintaining. There's a lot of there's a lot of times as a senior engineer or architect when you're doing this code, you're setting it up all as perfectly as you can, and then you're telling your developers, hey, from this code, don't call directly into the database, or from this code, these are the rules, don't do this. And then you're afraid to ever take vacation. Because the moment you go on vacation, you're done. You got to come back. Someone else is doing the code reviews. This is a big mess. That's the way it usually is. So in service-oriented programming, if you set it up, I would say correctly, the way that I do it, I guess, the way that is recommended by a lot of places that I see, then it's self-maintaining. So domain models, as far as setting up your projects, how you split your projects up in your solution, where you put things, the domain model should have 0 references to other projects. If your models have a reference to another project, that means it's calling dependencies or it has some sort of process it's doing, then that's a code smell. If you separate your models into its own project with no other project references, there's no way anyone could do that. So usually, even if they try to do that, it just won't work. It's perfectly fine. The core. In service-oriented programming, you would separate something called a core. So you might see in NuGet or Maven or whatever code base you use, you'll see core projects. And these core projects have models or interfaces or something to do with the system that isn't the implementation. And so the core should also not have any references to anything else except for the models project, because all of your signatures that have models, that return models or taken models, of course, it's going to need reference to that, so that's the only reference it should have. Your actual services, this is your domain or your actual business logic. It references the core so it can implement those interfaces, and of course references the models so that it can use those models, take them in and return them. The service domain should also, of course, reference any dependencies it has. So anything to a .data project, if you're doing NTIER'd, or to any type of other microservice or SDK that you're using, it should have, of course, a reference to those. So that's where all of your reference architecture really builds together, is inside the domain. And also for self-maintaining, there's the dependency injection rules. So since models don't have any process or dependencies, there should be no dependency injection. There should be no references to anything. The core interfaces don't have dependencies. And services, of course, your services usually have dependencies. They should be constructor injected. Any of your services should be constructor injected. You should store those injections in private fields, and your services should be persistent ignorant. So even though I may be consuming a core that is using Entity Framework, my domain shouldn't know that you're using Entity Framework. Your domain should just know that you are using an entity that is perhaps a customer entity or something like that, and it should just be working with the entity and the entity model, or the models for the customer, but it shouldn't know that you're using Entity Framework. And your services also shouldn't know that something's consuming them. So if you're using a web API to consume your domain, or if you're using some sort of a Windows GUI or some sort of a mobile application, your domain shouldn't know anything about that. And now coding rules. When you're programming, service-oriented programming, the models should have limited private code. Models in service-oriented programming are anemic. They don't have much process to them. They have a bunch of properties and properties of other models, which are more properties, but they don't have any business logic to them. That is not the same as saying that they don't have any business rules to them, which makes them less anemic than anemic used to be back in the day. But any of that code should be public code, something to do with setting a property or how you're using the class, but it shouldn't be private code. Interfaces don't have code, so there's no coding rules for that. And the service is where all the code lives. Almost all of your logic in service-oriented programming should be in pure methods. That is, you will have an interface. You'll have an interface to your service, a customer service, for example, and the interface will expose what functionality you want to someone else, and all of those properties will, all of those members will do all of the orchestration, which means I'm going to do this business logic, I'm going to store this in the database, I'm going to take it from the database, and it's going to be handling all your state and all your persistence. But you take all of your business logic out of that and you put it inside of pure methods. And in those pure methods, you make those pure methods static. That makes them very testable. If you have static pure methods, then you never need to worry about any side effects. It's just like functional programming. Then all the orchestration happens inside of the interface, the exposed interface methods. So the benefits of that are test-driven development. When you're doing test-driven development with service-oriented programming, it is super easy because all of your business logic is in static pure methods. That means you don't have to worry about mocking dependencies, and that's a huge benefit. You don't have to worry about any of the complications. Your tests are so easy. You just assign act assert, and you're done. You call into a static method, you pass it exactly what you expect, and you get back exactly what you expect. It's easy to DTO domain models with consumers. So since all of my models are, they don't have any process in them, they're just properties, then what you can do is you just pass that around to whoever needs them. I don't know if anyone here has seen this before, but you have some sort of a code base where you have a customer model, some sort of a model, and the person consuming it, in order to deserialize your model, has to also have a customer model, and it has to match exactly. And if a change is made inside of the domain for the customer model, then the person consuming it also has to make the change to their customer model. So that's something that you get here, since the bad idea to pass around objects that have functionality in them, and I'll get that in a second, it's a Martin Fowler law. Since it's a bad idea to do that, no one ever did it before, so they made DTO objects and they had to copy them on both sides. But since there's no logic in service-oriented programming mixed in with your models, you can pass them around as much as you like, and I get into that more here in a second. And scalability, of course, is a big benefit of service-oriented programming and microservices, but there's a cost to that. So service-oriented programming is inevitable. Like I said, it's something that a lot of us are already sort of doing if you're doing layered design. So when you favor composition over inheritance, then you eventually don't have any inheritance or polymorphism at all. What you end up doing is you say, instead of a heart inheriting from I vein because it has the functionality of veins possibility within it, you say a heart has veins. That's favoring composition over inheritance. Because things are made up of other things. They don't just have functionality of other things. Your models eventually model the true real world with composed hierarchies instead of categorical. So when you're thinking about the diamond problem, I don't know if anyone's here, the diamond problem with interfaces, that means like a copier has the ability of being printing and scanning, and so you have iPrinter and iScanner as your interfaces that copier implements, and so it can do all the same stuff as that can do. But it also, those two have an interface, shared interface, where they share powerable object or something that has electricity. And so whenever you're implementing that inside of your, I usually have my notes here, but I don't remember what it's called, your copier object, you now have to implement your printer and your scanning abilities as well as the power ability. And so since you have an iPowerable and it's iScanner and iPrinter, and then your copier has to implement iScanner functionality, iPrinter functionality, and the power ability that they both inherited from their interface. So you can't do that because you don't know which power one you're using, which one you're not. That's called categorical inheritance. So a categorical hierarchy. It's not true to the real world, where instead everything is sort of more composition. It's composed hierarchies. My copier, yes, it has printer abilities, so it should have a printer object, and it has scanning abilities, so it should have a scanner object, and it has its own ability to power things on. Modeling your domains start to look more like the real world if you do composition. So service-oriented programming patterns. Like I was saying before, many OO patterns exist to take process away from the model. anything that's a builder pattern, and, take that away from there, let's build a repository, take that process away, let's make a builder. Anything that you say, take that process away from the model, and let's create a pattern that does this process over here somewhere else. That's moving towards service-oriented programming. Single responsibility principle and interface segregation principle. If you watch any videos on SRP, then you'll end up seeing something like, here's a customer or some sort of an object, and it has all of these different responsibilities it's taken care of, and they'll say it should only have one responsibility. Which one do you choose to keep in there? It doesn't make sense to take out some of them, but not all of them. So when you start doing that, then you just leave some random functionality inside the customer that, it's single responsibility, so it's got to have at least one. In service-oriented programming, you take all of them out and you put it inside of a service. Now, you still follow the single responsibility principle for services, though. So for a service, you would say, let's say for employees, the person in charge of HR has these responsibilities. They need to hire people, they need to fire people, they need to give people pay raises and give people recognition and all the responsibilities that HR has. So you take those responsibilities of a real person and you make those single responsibilities into services. So you'd have a hiring service, a pay change service, a recognition service, and these are actual single responsibilities of a real person in real life. And so you would make these services, and these services all handle the employee object. The employee object would have all the properties of an employee, including their pay, their name, their whatever else an employee needs to have. And you would pass that employee object to the services and have the services change the state of the employee object. The services, of course, always staying stateless themselves. So single responsibility principle, when Uncle Bob talks about it, he actually says these things that you're talking about the responsibilities of a person, not the responsibilities of a class. You might hear all the ideas of, a square is not a rectangle, or this class should only do one thing, and how do you define what one thing is? In a lot of his talks, he'll say, think about a person, usually a C-level person, and what their responsibilities are, and that's the way that you should model these responsibilities. Interface segregation principle is very similar to single responsibility principle. You want to separate it out into, you want to have low coupling and high cohesion. So you want to say, yes, the one responsibility is the ability to do recognition. That doesn't mean you just have the recognize method. You have anything to do with recognition, which means the ability to take a poll from your coworkers and say, who do you think deserves recognition, and all those sort of cohesive responsibilities about recognition, and put them into one thing, but separate them out to have low coupling. Gosh, dang it. TDD and IOC, another thing that makes service-oriented programming inevitable. When you're doing test-driven design, unit tests don't work well with state. If you have a bunch of state in your application and you're doing a unit test, then you call a unit test one time and you call it a second time and it's a different result. State is not something that unit tests do well with. So when you're taking all of the state out of your programming, then you're separating your process from your data, and you're getting away from object-oriented programming, you're getting into service-oriented programming. So anything that you're doing test-driven design, or you're making things mockable and you're taking state out of everything, then you're sort of forcing yourself to move towards service-oriented programming unless you're really holding on tight to those object-oriented principles. And you can clearly see if you're doing true test-driven design where you're writing the tests very first based on the business rules that a business person gives you, then you're sort of forced to put it in places that are services and separate your logic into different modules, and then, of course, afterward refactor. And you're sort of forced to do service-oriented programming. It just sort of happens. So this is an anime joke. A lot of people can't really tell the difference. It's very important. It could save your life to know the difference. So service-oriented programming versus procedural. To cut to the chase here, service-oriented programming is more like functional programming than it is like procedural. Functional programming, there's a lot of functional programming you could be doing in service-oriented programming if you're not already. It's not something everyone's doing, but it is very beneficial to you to make those pure methods so that they do the same thing every time. It makes it super testable. It's more like functional than procedural. Object-oriented programming is the act of state and methods living together. Functional, service-oriented, and programming all separate state from procedure. But in functional and service-oriented programming, you dictate the majority of your design to pure methods. In procedural programming, you have a global state, you have module level local state, and you're changing the state of those things or changing the state based on whatever the actions are. It's not the same as functional programming or service-oriented programming. And of course, that's another thing that I say because I've heard it before. All rules are written in blood. A lot of people say, you're just doing procedural programming. This isn't object-oriented. It's not supposed to be object-oriented. It's service-oriented. It's closer to functional than it is procedural. Microservices. So, service-oriented programming, the whole point of service-oriented programming is to get to something like microservices. It's making your code more modular, making your code more scalable. So microservices, how do they fit into service-oriented programming? Well, service-oriented architectures are a combination of you create the service-oriented programming, and then you find a way to expose the service-oriented programming so that people can consume it. So creating a microservice is just the act of taking it and exposing it to something over something like Web API or something similar to that. TCP is an option for microservices. So if you're behind a firewall, everything is secure. You don't have to worry. You still worry a little bit about authentication and authorization. But if you're behind a firewall, it's not a huge draining resource on your microservices. TCP is much faster than HTTP. It is, if it's on premises, it's from server to server, right across a switch, it's super fast, then that's one method that you can do. It's the fastest method, well, not the fastest method you can do. HTTP, though, is the slowest method you can do. This is Web API, or something similar to that. And the idea is you have some Web API classes, some API classes on the front that then consume your domain, and they say, I'm going to expose this functionality in your domain so that people can call it from the outside. Another thing that's so slow with that is that since it's exposed externally, you have to have very strong authentication and authorization. And so that slows it down even more than the fact that it's just HTTP, which is very slow. So do you even bandwidth, bro? Martin Fowler said the first rule of distributed objects is don't. That's his rule for distributed objects. The idea of distributed objects is, like I was saying before, in object-oriented programming, you have a customer model with all the functionality that a customer can do, anything that a customer needs to do, make payments or send emails or message or whatever customers need to do. And when you distribute those objects, for example, you have multiple servers running, because you want to scale out, you want to have multiple servers running different versions of those objects, and you want to have other microservices calling into those remotely, then it makes things very slow because you have a whole bunch of methods that a customer can do, and it's very fine-grained as an interface with, you have hundreds or thousands of methods across your domain. And now every single call you make has to be over HTTP because it's distributed, and it makes things very slow. So the idea is don't do it. It's super slow. And I agree, of course I agree with Martin Fowler. Martin Fowler more recently said for microservices, it's okay to do microservices as long as you have coarse-grained interfaces. So there might be a lot of stuff happening behind the scenes for a customer or customer service or however you have your setup, but that doesn't need to be exposed to the outside world. The outside world may take more like batch processing. It could have something like, do all this stuff for a customer, and so it'll decide everything it needs to do in batch behind the scenes, or it can more generically have just super generic or coarse-grained functionality that's exposed, and behind the scenes it'll decide which of the more fine-grained things it needs to do. There's new tools that we have. A long time ago, all these rules came out and people were saying service-oriented programming is bad, or service-oriented programming it's not going to catch on because it's so slow, or I know it makes it sound bad, but microservices don't have to be distributed over the network. Microservices can now be distributed via NuGet. You can have a local NuGet package, you can have all your functionality and services, and you can distribute those services to be consumed by other services directly as code. So since instead of having a GAC or DLL, how we used to call it, you could have NuGet, which keeps versions updated, and it's really easy to update your code, and everyone has the same copy or the copy that they need. So there's NuGet. It was invented in 2010. Maven's been around for a long time, but it became more like NuGet when NuGet came around. And NPM and Bower, of course, have a huge number of libraries. They're the biggest. So all those .core that you might see in NuGet, all the .core package and the .core packages in NPM and Bower and that sort of thing, that's because people are using service-oriented programming and they're separating their functionality out. So distributed, you could have SDK packages. You could have SDK packages that take your code and they directly expose it so that an HR service could just directly implement your customer SDK, and it could just directly use the code. There's nothing going over TCP, nothing going over HTTP. Everything's just right there, and it's super fast. It's on-prem. So, but another idea is HTTP and TCP. You could have an SDK that understands what your endpoints are, what your endpoints need, the authentication it needs, what the RESTful route is, and it could say, I will expose this to you as a method, and I will determine how I'm going to make the call up there and how to serialize the information and deserialize the information. The SDK would have the models that come along with it, so you could package up your models for your domain into your SDK, and you could pass that on to someone. Then they won't have to know what all of your calls or the calls that you expose. It makes your microservices very discoverable and documented, and they can see everything that they can do. Also, that is very fine-grained, so that it'll say, these are the 10 things that you can do, and with those 10 things, we'll send up either bulk processing or sort of more of a, this is the generic thing I need you to do, and it'll determine behind the scenes how to split that up. I already talked about NuGet a little bit. So anemic models. Anemic models is another thing that you'll hear bad things about. You'll hear people saying, why is all your functionality over here in this service? That's not object-oriented. Anemia is bad. If you Google anemic models, you'll see a lot of things about how anemic models are bad from back in the day, from a long time ago. But when you show them how your anemic models have all of your business rules in it, not necessarily your logic that goes in your service, but business rules, such that when I instantiate a customer, I need to make sure that I instantiate them with an email address. Otherwise, it's not a valid customer, because according to the business rules, a customer requires an email address. Those type of business rules, the way that you set the properties, the way that you validate when a property is set, when you use value objects, all of that there's a lot of logic that could go into one of these anemic models. So when someone looks at that and you say, here's an anemic model, then they'll say, that's not anemic, there's a whole bunch of business rules in there. Of course, when you don't tell them it's anemic and you say, here's my services, and the only thing in the model is some of these rules, and they'll say, oh, it's anemic, that's not bad, so you really can't win either way. So it's not the same as it used to be when anemic models were really just DTOs back in the day. There's a lot more to it these days. Gosh dang it. Serialization is another tool that we have that's different from decades ago. So we have in C#, of course, we have Newtonsoft. So Newtonsoft can serialize things with JSON and then deserialize it in JSON. It can decide how deep it wants to go whenever it's doing serialization. It could do self-referencing serialization, cyclic references. It can do lots of things. That's not something that really happened a long time ago when we had XML, and these days XML can handle a lot of those, but back in the day, XML was just XML. And serializing, deserializing was very complicated, and is another thing that put people off from distributing their models. So service-oriented programmers are like screws. They're slower. A hammer, of course, you can just hit hammers and nail them in. Screws are a lot slower. You have to use a tool, special tools, coarse-grained interfaces to use them. Of course, they hold a lot stronger. It's just metaphors. Internet of Things. Internet of Things is totally service-oriented programming. Microservices, all of your objects that are, they have their boundaries. A refrigerator is going to send up information. Hey, I have this. Anyone that wants to consume me, I'm sending out these events. I'm low on milk. I'm whatever it is. It's all service-oriented programming, microservices. Their interfaces are very coarse-grained, and they don't care who's receiving their information or who's sending information, partially to a point. So that's another benefit of service-oriented programming. Microservice, death of the bus. So everyone's probably, I'm assuming everyone's heard of Enterprise Service Bus, Microsoft Enterprise Service Bus, or some sort of bus. Service buses are very powerful tools that were made to solve problems related to business process management. I'll create a service bus and it will consume all of my WCF services or all of my services that I have. I've distributed my objects even though Martin Fowler told me not to. And I now need something to manage that and just determine which way to call it, how to log when something's called, how to perform my cross-cutting concerns, not just logging, but also authentication, all that sort of stuff. And I'll make a service bus that does that. And the service bus will also handle my events. It'll say, okay, these are all the events that are coming in. I will decide how to consume those and when to send them out and who to send them out to. Microservices handle all that stuff. So if you have a microservice architecture set up correctly, then your microservice will log when things come in. Your microservice will send out events whenever it has an event to trigger. Things can either subscribe to your microservice or you have a sub-microservice that is the event microservice. And the event microservice everything that sends events could send events to that. Anything that listens to events can listen to events from that. And it's just another microservice. That sounds like a service bus is also just another microservice that you send information to, and it's just part of a microservice architecture. So you could say that a service bus has been downgraded from being this center of your world where everything needs to go through this big service bus that is now the center of your world, and downgraded to just another microservice, just another detail in the system that information can communicate with. Whenever you're doing service-oriented programming, or hopefully any programming, the domain needs to be the center of your world. This is the domain for the customer. This is the domain for HR. This is the domain for the employee, the domain for the order service. And that domain is the central driver. What they depend on, like Entity Framework or something like that, those are details. We don't care. It depends on SQL Server. We don't care. That's a detail. It depends on Android as your UI. We don't care. We'll implement something else we want to. It depends on Microsoft Enterprise Service Bus. We don't care. That's not something we care about. We're just going to downgrade everything to being an implementation detail, and that is put off to the side, and we're going to focus purely on our pure methods and our test-driven development, our service-oriented programming, and that's our center right there. I had nowhere to put that, but I thought it was funny, so. Okay, so service-oriented programming means you separate data from process, opposed to combining data and process. Domain models can still have validation rules and value objects, so they're anemic, but depends who's looking at them. Service-oriented programming handles business logic through services, and it pushes persistence and state to the far boundaries. We don't care about that. That's sort of an implementation detail. And service-oriented programming owns its domain models. I didn't really touch on that fully, but if I have a customer microservice, a customer service, it has a customer model. That customer model can be then consumed by other people when I expose it to them. I give it to them through this SDK that I've created, but I own it. Whenever I make a change to the customer, I'm the domain. I own that customer. I make a change, then you download the NuGet package. The change is there for you. That's great for you, but the point is I own it. If you are running Razor, you're doing a Razor GUI, and you are implementing my domain, Razor suddenly says, oh, in order to validate this email field, go back to that property on your model and put an attribute on there that says this is a regex pattern that has to be followed. No, you keep that to yourself. What you can do is you can have a thin layer between the domain and the GUI, and you can have your own DTO if you want. You can create a view model, as of course you call it. Create a view model, put your attributes on there, mess with it all you want, translate the domain model to that. I own the domain model. I'm the customer. Don't tell me to put some attribute on it. The domain is the god of the domain. Service-oriented architecture means you're doing service-oriented programming and you're now exposing that service-oriented programming over HTTP or TCP or directly with NuGet with some sort of an SDK saying, here you go. And the slower it is that you're exposing this, such as HTTP, the more coarse-grained that you want your interfaces to be. So if you're doing an SDK that just directly pulls in the code from your model, from your domain, and saying, okay, you're going to go ahead and use this, you can just directly interface with the core, which is your interfaces, and say, you can call any of these methods because it's right there, it's instant, no big deal. And if you're doing HTTP, then you want super coarse-grained interfaces that says, you got these couple of calls you can make. We know what you mean when you do these calls, and we'll do all this bulk processing, and we'll decide what to do with it. I guess that's it. I thought I had a final slide. All right, that's it. So go ahead and throw on some questions and comments. Yeah, F# and C#. Now, that's sort of, or I guess the real answer, the question was, what languages do you like to do microservices in? Object-oriented languages. I know that's funny. The object-oriented language doesn't mean that you have to be object-oriented development. Object-oriented development and an object-oriented language is two different things. Object-oriented development being marry your process with your data, and object-oriented language meaning we have simplified the language or made it more efficient to do inheritance, polymorphism, and encapsulation. So these languages, since they provide you with any language that provides you with the ability to do test-driven development, gives you the ability to use interfaces and to do interface inheritance. These languages are the best ones to do microservices with. So yeah, C# and F# are the best. If you do your domains in F#, you do all of your pure methods in F#, all your testing in F#, and then you implement that into C#, and you just do your wrapper methods in C#, or anything that's impure that interfaces with the database in C#, then that's ideal. Good? All right. Thank you for listening.